Hello, students. Welcome back to our next segment in this very energetic topic, nuclear energy. And yesterday we talked a little bit about nuclear energy, summarized some of the concepts, and we talked about nuclear fission. And we ended, I believe, with nuclear power plants. So let's begin with probably the world's most famous nuclear power plant of all, found in The Simpsons. And so here we have a most intelligent individual running the world's most famous nuclear power plant in his town. Homer Simpson, the world's foremost radioactive or nuclear scientist. Let's call Homer the world's most famous nuclear scientist here. Now, in all seriousness, we have discussed over the last week the pros and cons of nuclear energy. Let's just focus in the next few slides about some of the problems with fission. Again, our nuclear power plants currently in our country and around the world for that matter still utilize nuclear fission, the splitting of atoms, and there are some problems associated with fission in general. First on the list are radiation leaks, and there can potentially be releases of alpha and beta particles. We know those symbols from last topic, as well as gamma radiation, gamma rays. And the release of radiation can certainly affect the lives of plants and animals, including us humans. And after today's lesson, I'm going to show you some videos which will demonstrate and illustrate the long-lasting effects of radiation leaks from nuclear power plants. The second major problem with fission in terms of nuclear reactors are things called meltdowns. Now, we're not talking about the kind of meltdown that a little toddler experiences when he's a little overtired or hungry. We call that these days being hangry, hungry and angry. No, the type of meltdown we're talking about here has to do with the situation that arises when the nuclear fuel exceeds the melting point of the surrounding material. When that happens, bad things occur. I'm going to show you a video of what takes place during a meltdown, so stay tuned for that video. But meltdowns are certainly not things you want to experience if you are anywhere near and especially in a nuclear power plant. So basically, you've got your containment facility that no longer can contain things because the chain reaction is essentially running completely out of control. And that is probably the most feared thing that can take place, the biggest problem that people are concerned about when thinking about nuclear power plants utilizing fission energy. There are three really famous examples. 3 Mile Island on the Susquehanna River. 3 Mile Island is a place in Pennsylvania, not far from where we are, and in 1979 experienced the partial meltdown and basically put the brakes on future nuclear energy development in the United States. That certainly was not a very good public relations experience here in the United States. I remember 3 Mile Island vividly. In fact, I was about your age when 3 Mile Island took place, and there was a lot of talk and a lot of fear about radioactive poisoning even hundreds of miles away from the nuclear reactor. And then in 1986, a much worse uh, problem occurred in Chernobyl, currently in the Ukraine. And Chernobyl, I'm going to show you a video with Chernobyl and the long lasting effects of that nuclear meltdown in 1986. More recently, only, gosh, maybe 10 years ago now, we had Fukushima. The Fukushima nuclear meltdown took place in Japan, and there is a whole series of events that occurred that caused the loss of backup power in the nuclear power plant and resulted in some explosions and the result of radioactivity in the environment, in the air, in the water, and had caused an enormous uproar around the world as far as continuing the use of nuclear energy. And again, this nuclear concern that so many people of our generation have is this meltdown experience. In this diagram, it kind of shows a containment vessel with the nuclear rods that heat up in order to generate the electricity. But if for a variety of reasons that containment vessel can no longer contain the out of control nuclear reaction generating enormous amounts of heat, well, that nuclear material can melt down through the containment vessel. Back in the 70s, I think it was around the time of 3 Mile Island, there was a movie that came out. I believe Robert Redford and Jane Fonda were in the movie. I might have those names wrong. And it was called The China Syndrome. And the reason they called it the China Syndrome was because there was a belief that if a nuclear power plant here in the United States, like 3 Mile Island, were to have completely melted down, the radioactive waste would melt down and through the entire planet and come out the opposite end, which is geographically China. So that's where the term the China syndrome actually comes from the fear of a complete nuclear meltdown in a nuclear power plant. So there's some concerns and problems associated with nuclear fission and nuclear energy. But there's a lot of research being done right now. Billions of dollars are being spent in a new kind of technology when it comes to nuclear energy. And that is utilizing not nuclear fission, but nuclear fusion. Nuclear fusion is the type of nuclear energy that our sun actually utilizes. And nuclear fusion with a U is the combining of two atomic nuclei, typically smaller nuclei, in order to produce one larger nucleus, and again, the release of an enormous amount of energy. So in this diagram, we have two radioactive isotopes of hydrogen called deuterium and tritium. And they're called that because deuterium means deut is a prefix for two. Tritium, tri, is three. Has to do with the number of neutrons in the nucleus of an atom. And so deuterium, tritium, two radioactive isotopes of hydrogen, the smallest of all atoms of elements on the periodic table. If you are able, as the sun is able to do with an enormous amount of energy because of the tremendous mass, the amount of matter that makes up the sun, the gravitational force is sufficient in order to squeeze these hydrogen atoms together to cause them to fuse with one another. And if you can get these isotopes of hydrogen to undergo nuclear fusion, the result is helium, nothing terribly dangerous or radioactive about helium, and the release of an enormous amount of energy. And the interest in nuclear fusion is just that. The interest in nuclear fusion is that it produces more energy than fission, number one, which already is a lot of energy, but it doesn't release those radioactive products that fission results in. So, and we're working feverishly to try to find a way in order to produce nuclear fusion, and there are many attempts at it, but so far, it requires more energy to compress those hydrogen atoms in order to make them fuse together than the amount of energy that is released. So I would imagine that at some point within your lifetimes, maybe not mine, I don't know, but maybe, who knows, maybe within a few years, we'll develop the technology that is actually required in order to fuse atoms together without using an enormous amount of energy, so that the energy output is greater than the energy input. Because once that is achieved, and who knows, maybe one of you watching this right now will be the one to figure out the methodology to achieve this goal. In fact, if you could, you'll become the most famous person on the planet, the wealthiest person on the planet. You'll win a Nobel Prize in physics, undoubtedly, and you will solve the world's energy problems. Because once you are able to get a nuclear fusion reaction productively, my goodness, you will be producing essentially free energy. Because there's plenty of hydrogen in the universe to utilize, and without any radioactive, nasty products as a waste, that would be wonderful. If you've ever seen the movie trilogy Back to the Future, you know that the doc in that movie utilizes nuclear fusion in the future with the Mr. Fusion adaptation on his the DeLorean time machine in order to achieve time travel. But hey, that's an issue for another topic, or that's a topic of another issue, or that's something we can discuss at a later time. All right, so we've discussed nuclear fission yesterday. We've discussed a little bit of nuclear fusion today. I want to show you those videos, especially the ones about those 3 famous accidents that have taken place, the 3 Mile Island, Chernobyl, and Fukushima, and also show you what a nuclear meltdown, the China syndrome, is all about. So for today, I think I'm going to call it quits, and we'll save the rest of our notes for tomorrow. So until tomorrow, let's say bye-bye.